My name is Daniel Gingerich. I'm a postdoc here in the Water and Energy Efficiency for the Environment Lab, and my work looks broadly at integrating large publicly available data sets with models of engineering system performance, environmental impact, and the cost of technologies. And I have two distinct projects going on right now here within the lab. The first project is looking at modeling trace element partitioning at coal-fired power plants using the trace element partitioning, or TEP model. This model takes information from the public literature about the quality of coal, so the trace element concentrations within it, as well as information from the literature, the Energy Information Administration, and then actual observations at plants as part of a grant with the National Energy Technology Laboratory. And using these data sources, what we built is a model that's capable of predicting the trace element concentrations in combusted coal, as well as the mass of trace elements leaving coal-fired power plants across the nation in the gas phase, solid phase, and liquid phase. And using this model, we've sought to answer questions on how regulatory drivers have changed the trace element mass flows from coal-fired power plants, so how things like the 1990 Clean Air Act amendments affected things. Some of my ongoing work in this is also looking at water pollution control and wastewater treatment. So can we use a model like this to inform regulations and compliance decisions for wastewater discharges from coal-fired facilities? The other project I have going on right now uses a model that we call the Water Associated Health and Environmental Air Damages Model, or WATER AHEAD, which is a model that takes information on the electricity sector and chemical sector, integrates it with a unit process library that has for over 50 drinking water, municipal wastewater, and industrial wastewater processes, the chemical and electricity consumption, and then integrates this with information about where these processes are located in order to estimate the total embedded air emissions associated with water treatment. We then use marginal damage models to assess the total air emission damages from water treatment across the country. In the past, we've looked at ways that we can measure and integrate these air externalities into regulatory and policy decision-making. And some of my ongoing work looking at these models thinks about how we can use externalities, especially climate externalities, in order to evaluate technologies and guiding technology development for future electrified water treatment processes.